Find dy dx for y equals 3 secant x over x to the 8th power. All right, so here we have a quotient of two functions. So I'll set up the quotient rule for derivatives. So the numerator is 3 secant x. The denominator is 8x to the 8th power. All right, so the derivative of the numerator. The derivative of secant is just something you need to memorize. It is secant x tangent x. The derivative of the denominator is 8x to the 7th. So these two values here multiply together, and that gives us the product for the numerator. So this derivative, f prime, or if you want to call it dy dx or y prime, I guess I should use a y because it's y equals. Either way, as long as we know what we're talking about here. It is, let's see, maybe I'll write it 3x to the 8th secant x tangent x minus 24x to the 7th secant x all over the original denominator squared, so x to the 8th squared, which will become x to the 16th. And this is a perfectly fine answer, but if you'll notice, there's 7 factors of x here, there's 8 factors of x there. We could do some canceling. Effectively, you're taking out 7 factors of x in the numerator and the denominator. And you can do that because you would just be effectively dividing it over itself. So this would be 3x secant x tangent x minus 24 secant x all over, this is x to the 16th. When we divide that by 7, it becomes x to the 9th. So there's a slightly simpler form. If you wanted to continue, which you absolutely don't have to, you could pull the common factor of 3 secant x out of the numerator, and that would leave you tangent x minus 8 over x to the 9th. And honestly, the only reason you might do that is if you were to use the derivative in another step of the process, or if you happen to be just wanting something a little easier to type into your answer box.